so test number 8, lessons 29 down through 32. A lot of it is going to deal with our derivatives, antiderivatives, integrals, differentials. So a lot of this is going to sound very similar, but just slightly different with how we set up the questions. Beginning with lesson 29, where we talked about our differentials of a sum. If your equation says y equals, let's do 3x to the negative 2 plus 4y cubed minus 7. Right? And the question here says to find a differential. When you're doing a differential, it's just like doing a derivative. There's just one extra part that you need to put on the question. When it came to doing this with a sum or with a difference, you just do each part individually, and then we put that extra piece behind each of the different sections of our question. So in order to enter the differential, it would technically be called, let me not put y back here because I called the function y. Let's change this variable to a z back there in the question. All right, so the differential with respect to y, or the differential of y. Alyssa, can you begin by giving me the derivative of 3x to the negative 2? Very good. So that's when we drop our exponent down to the front. So negative 6x, then we subtract 1, negative 3. What extra piece do I need to include, Alyssa? Because I'm doing a differential. Dx. So I did the differential with respect to x. That was our variable, so we have a dx. Josiah, how about the second part, the 4z cubed?
So it'd be 12z squared dz.
Very good. So our variable this time is d, so I did differential with respect to z. We dropped the exponent down to the front and then subtracted 1. Amelia, what about the constant there at the end?
0.
It's just 0, so I don't need that. And this would be my final answer for the differential of that kind of sum. Okay, we're good. Question number 1 there. Yes, sir?
Would you want to put your x in the denominator so it was positive or no?
We usually didn't when it came to a differential. If you wanted to switch this to negative 6x to the third, that's okay. All of a sudden our book stopped doing that when it came to a differential. I'm not sure why all of a sudden they stopped, but they did, so I don't care which one you give it to me as. All right, let's go to another example here. Let's try 2 over x to the negative 3 minus 4 cosine b plus 5 ln x. And let's go with ln a since I already used x, just to give a different variable. All right, again, our goal here is to use a differential in our question. So differential, just like you're doing a derivative, we just add that extra part at the end. Now, before I do the derivative of this first part, what do I need to do first? Anna, do you remember what I do first on this part of the question?
Make it positive.
I make it positive, so I don't want the fraction, so I'm going to move that up to the front, and this part is really 2x to the third, then in the problem. All right, so Anna, can you give me the differential for 2x to the third?
6x squared dx.
Very good. All right, so drop your exponent, subtract 1. The variable's x, so it's dx. Alyssa, what about the second part of our question?
Plus 4 sine dz.
Very good. All right, so the derivative of cosine is negative sine. So a negative 4 and a negative sign make positive 4. The variable is b, so she ended with db. Josiah, what about the last part of this question?
5 over x a dA.
Close. Okay. Listen, the derivative of ln x is 1 over x. The derivative of ln y is 1 over y. So can you change your answer then?
So it would be 5 over a
There you go.
dA.
There you go. Okay, so don't think the ln always has to go with 1 over x. That was just the case if the variable was x. Our variable is a, so we're going to put a in the denominator. And again, because it is a, we end with dA. And there is your differential in your question. It's starting to fall, Josiah. Now I'm getting concerned. Alright, good on that one? Alright, let's do one more differential question just so you can see some of the different setups that I had on our test. The last one, let's go the fourth root of x plus 3e to the, I keep using x, e to the b. Amelia, do you remember what I need to do first with the fourth root of x before I do its derivative or differential?
Change to x root on 4.
Very good. So to go from a root to a rational exponent, we kept the base the same. The index gave me the denominator, and the exponent went into the numerator. Can you go ahead and continue there for me, Amelia? Give me the differential for x to the 1/4.
1/4 x to the -3/4 dx
Very good.
plus.
Oh, you're going to do the whole thing?
Sorry.
Go ahead. You go right ahead. You're fine.
Plus 3e to the b db.
Very good. So the derivative and the differential for e to something was the same. Our variable there is b, so db. All right, very good. On your differentials for sums and differences. Alrighty, our next 4 questions, I'm going to have a graph drawn for you, and then your job is to draw in the reciprocal of that graph. Your first graph will look something like this one. Let's go with this today. So it'll just be a line. Your job is to draw the reciprocal function on that question. Alyssa, do you remember what we do first to draw the reciprocal function? This may have been the day you were at, I'm not sure. Okay, so I have a 0, and I don't even really know what number it represents, but I have a 0 right here, because 0 is where it hits the x-axis. What did the zeros become for the reciprocal function? The asymptote, because reciprocals flip. The zeros were in the numerator, now they're in the denominator. So I'm going to put an asymptote at that one location where I used to have a 0 on the question. Josiah, what's the next thing? This will kind of be to finish up our problem.
You would need to draw your line, so the one that's far away, you would want to draw close to the asymptote.
Okay. So what's it going to look like over here?
Is it going to go down?
It is going to go down. Okay, so right here, so on the right side of the asymptote, everything is above the x-axis. Its reciprocal is still above the x-axis. Right here, I'm close to the x-axis. That means the reciprocal is far from the x-axis. As I continue to the right, I'm getting further away from the x-axis. That means the reciprocal needs to be getting closer to the x-axis, and that's where we drew in those little curves like this, going further away, and I'm getting closer to the x-axis. So based on that, Josiah, can you describe the left side as well for me?
So then that one would, it has to hit its y point still.
Okay.
So would it be a curve again?
It's going to be a curve again. What's it going to, where is it close to, where is it further away?
It's close to the x-axis because the line is further away.
Okay, so it's going further away here, which means I need to be closer to it up here.
And
Then what's going to happen as I get close to the asymptote?
it's going to go down.
It's going to go down. Because I was getting closer to the x-axis, the reciprocal is going to go in the opposite direction. So I'm going to head down, away from the x-axis on the picture. Next again, I don't have the equation written out. I just have the graph, and we draw something roughly like that on your question. Okay, are we good on the first one with the line? The other 3 graphs that I'm going to ask you to draw a reciprocal for are from our trig graphs. So let me attempt to draw one here this morning. Alright, so let's do this. Let's just keep my original one in black here. You guys know how good I am at drawing. Alright, so let's just say our picture looks like this. Alright, so Amelia, what's the first thing I'm going to have to do in order to draw the reciprocal graph? Drawing the asymptotes. The asymptotes are at every 0, and the zeros are where it hits the x-axis. So I have one here, another one. Here's again where it hits the x-axis. One more, and we'll finish with one of them. All right, so any 0 becomes an asymptote. And what do I need to do next to finish drawing my reciprocal function? So I got all my asymptotes in. Remember what we did to finish?
You put the zeros on the tops and bottoms of it. You could draw the dot.
You want me to put dots, like at the tops and bottoms of all the hills? We could do that. Because that would be true. These all will be 1 on your pictures. If it's 1 on the original, then it is 1 on the reciprocal. And I think one more thing. Remember that one other thing was? No? Okay. Let's try it, Alyssa. While we finish this kind of picture.
You do an upside down U touching the dot.
There you go. So the U is just kind of reversed. It was close to the x-axis right here between the asymptotes, so it needs to be further away. Over here it's close to the x-axis, so it needs to be further away, but it's got to hit that dot, so the U reverses. So the U used to be facing up, now it's facing down for our reciprocal. This U was going down, now it's going up for the next one between the asymptotes. Same situation here, it was going up, its reciprocal is now going to go down, reverse here, is going to now go up, and then this one's now going to go down on the question. And notice it's the same pattern continues to happen over and over again, down, up, over and over again in your picture. And you'll have 2 of the graphs will look very similar to that for you to draw in your reciprocal function. Any question on that one? Okay, last example on reciprocal functions. Any of you remember, this is the one I'm going to attempt to draw out right now, what did the graph for tangent look like?
It was like doing S's.
It was a bunch of S's. Did the tangent hit at the origin? Remember that?
No. It didn't?
It did. Okay, so it did hit right here, so there was a bunch of asymptotes in the picture already. And then in between all of those asymptotes were a bunch of S's. Right, and the reason why it did hit at 0, if you think about your Cartesian plane, the point that's out here on the 0 degree axis was the point 1, 0. Do you guys remember the definition of tangent in terms of your x, your y, and your r? It was y over x. Well, that means in this question I have 0 over 1, and tangent is 0 at 0, so it does hit right there at the origin on the question. All right, so if you had a picture that looks like this, how do I correctly draw the reciprocal? Amelia?
So start on one side, so if it's going that way, you start on the other side.
Okay.
So it's like the opposite.
Okay, it's going to be the opposite, so the S's are going to go the other direction, but I got to do a couple other things first before I draw in all the opposites of my S's. Just that?
Do you have to draw in your asymptotes?
You just draw the asymptotes, so they're switching. Anything that was a 0 is now the asymptote. So I have all of these are going to revert to asymptotes now. And what happened to anything that was an asymptote? It's now a 0, because those two things rotate. So here I had a 0, or here I had an asymptote, it's now a 0. Here's a new 0, here's a new 1, here's a new 1, and then there's 1 out here. Okay. And then as you said, Amelia, they now kind of rotate between our S's here. So let's see if I can draw this. So I'm going for the purple asymptotes. Now I'm going to look at this. Purple asymptote. So you are going to have, I'm going to tell you right now, I'm originally draw the tangent, I'm drawing the cotangent by drawing in the reciprocal here. You're either going to originally have the tangent or the cotangent function, so you're going to end up with this nasty looking graph like this. So if you need to have maybe some colors on the test to show, okay, here's where I was originally, this is what I now want. Although if you're doing this all in pencil, it might be a bunch of jumbled mess by the time you're done. And I don't want you to do what I did on my original class example, okay, which asymptote do I now want? So if you did maybe some colors, then you'll know, okay, the colors are the new asymptotes that I want on my question. All right, any questions on correctly drawing reciprocal functions there for me? All right, let's move on. I think that was lesson 30, where we talked about how to draw reciprocal functions. Now in lesson 31, we talked about how to do a derivative if you had a product. So let's begin with y is x to the third, y to the fifth. The directions here are going to say do the derivative. Now, at the beginning part of the test, you did a differential, which is very similar to doing a derivative, but it was a sum or a difference. You just do each part individually. That was not the case when we had a product in the question. Alyssa, do you remember how we did it when it was a product on the question?
Is this where you do the x thing and then derivative of the second term?
Very good. So for my derivative, I do the first term, so that's x to the third, times the derivative of the second. So what's the derivative of y to the fifth? 5y to the fourth. Then this was always a plus sign, and then it reverses. I originally used the first term, now I'm going to use the second term, so I have a y to the fifth times the derivative of the first. The derivative of x to the third is 3x squared. Just neaten that up by putting coefficients first, so I'm going to write that as 5x to the third, y to the fourth, and then 3, I'm just going to match it with the x first and then the y, so 3x squared, y to the fifth. The order of the variables doesn't matter, but I would like you to put your coefficient first on your problem here. All right, see if you guys can correctly write this derivative for me. If I made my function 8x ln x, 8x ln x. Actually, let me not do that because something weird is going to happen here, and I don't like sticking through something. Let's change that to sine x. I didn't like that because the derivative of ln x is 1 over x, then it's going to cancel the x from the first term, and that doesn't happen anywhere on my test. I don't want to throw you off with something. Derivative of a product is the first term times the derivative of the second, plus the second times the derivative of the first. So I'm just going to write down the work that I have. So I'm taking the first function, my 8x, times the derivative of the second, that would be cosine x, plus the second function, sine x, times the derivative of the first, which would just be 8. So my final answer, 8x cosine x plus 8 sine x. Okay, go get that as your answer. All right, let's go to our next section here. Next section is very similar to what we just did. Now you're doing a differential when it comes to a product. Let's make our first function. Y is equal to, let's go to the fifth, bless you, y squared. Alright, so to do the differential of a product is the exact same thing that you just did. Just don't forget the extra piece you have to put because it's a differential on the problem. Okay, so I'm going to put dw, the differential of my y question. Josiah, can you help me out with the first piece of my answer for the differential?
So be x to the fifth, 2y dy.
Very good. Okay, so we take the first part of our function times the differential of the second, so I do the derivative and I put dy because the variable is y. Anna, can you help me with the second part for the final answer?
Y squared times 5x to the 4th and dx.
Dx. So I use the original second part of the function times the differential of the first, so I do its derivative of the variables x, so dx. Again, just neaten that up a little bit, so coefficient first, and I have x to the 5th y dy. Coefficient first, again, I'm just going to match the order of the variables, the x, then the y, then I'll finish with my differential dx. Okay, so you'll have two of them, very similar to what we just did. The last two sections that you're going to do is very similar to what we just did on the quiz this morning. The next thing is our antiderivative. So the antiderivative, I give you the derivative, you're writing an original question. So if I tell you that the antiderivative is 1 over x. Amelia, what could you give me then for the original function? ln x. Okay, that doesn't have to be the only answer. This is a perfectly acceptable answer. You can put any number back there that you would want. So ln x plus 8, ln x minus 3. You could just end with ln x or put any number back there on the question. What if my derivative is 9e to the x? Alyssa, what would the original function be? 9e to the x. The derivative of e to the x was itself. Again, you could just end with that, or you can write whatever number back there that you would like to on the question. Our final section that you will face is then the integral section. Very similar to the antiderivative, we just have one extra piece at the end. So if I had the integral, and it said 2x dx. Remember, the dx at the end just that clues me that the variable is x on the question. Josiah, what would I need to write for the integral for 2x dx?
So it would be x squared plus c.
Very good. So for the integral, I'm including all of the answers, so I include plus c, showing I can put any constant there at the end of my problem. Last example. Alyssa, what would I do for the integral of cosine x dx?
Sine x plus c.
You got it. Sine x. Alright, so those are the things that you will see on your test on Tuesday. Any questions for me? We'll stop there for today. Monday will be our practice day, and we'll take our test on Tuesday. Any questions on the examples you saw this morning?
Isn't it regular sign?
You're going backwards. So you're saying what function gives me this answer? Sine function. So sometimes on the test you're going the normal direction, near the end you're going backwards in the problem. So you just gotta make sure you're doing the right one at the right time.